Hi there, my name is Grant Scanlon. In this video we'll be building some traditional hardwood steps for the back door of a house. We're currently remodeling the house that was originally built back in 1890. Everything we do on the house, we want it to look like it was built back then, which is why we're using hardwood and traditional techniques for these steps. We have already built a landing off the back door when we extended the house a few years ago. The landing is supported by a cantilevered hardwood floor beam that unfortunately has a bit of a twist in it. But it won't be seen in the end, so it's just a matter of working around this. Even so, the cantilevered beam is more than strong enough. On the ground here, we have a couple of hand-poured concrete stumps that we also did when adding on to the house. These stumps are a bit like an iceberg. They actually go 900 millimeters into the ground, or 3 feet to those of you who are measurement challenged, and 450 millimeters or 18 inches in diameter. So what you see here is just the tip of the iceberg, and they're going nowhere. Because the molds we used to pour the concrete were made for longer stumps, the tops of these ended up being a bit rough. That's what one of these are used for. A big ass angle grinder with a diamond cutting blade that cuts through concrete like butter. We can use a straight edge clamp to the stumps that is level to find where the top of the stumps should be. We'll make this 1200 millimeters, which is about 4 foot, from a reference line which is the bottom of the chamfer boards. Then mark this with a pencil. We can then use a level to mark the other sides. We then start cutting with that big ass angle grinder. This saw can only go 60 millimeters or 2 and a bit inches deep, so we'll need to work our way around. We can then break away the bits we want off with a lump hammer. Then cut away the bit left over with the angle grinder on a bit of an angle, then kind of grinding away the last little bit, leaving a nice flat surface. Then we repeat the same with the other stump. Oh yeah, that's a nice dusty gritty job. Ugh. Now the tricky part, working out the height of each step, how many steps we need, the spacing between steps, and how they line up with the landing and the stumps on the ground. Firstly, we need to know how far the stumps are from the landing, so we use a level to mark the outer face of the stumps on the chamfer boards. Then measure how far this mark is from the landing. It comes to 1810 millimeters, which is around 6 foot. Or to be more accurate, 5 foot 11 and a quarter of an inch. What a stupid measuring system. We'll stick with metric from now on. We then need to put this to pen and paper. Well, draw it to scale on a computer, that is. It's not 1924. Here we have our landing, that is technically the top step, and a desired finished ground line. That is technically the bottom step. From the landing to the ground is 1456 millimeters. I can't imagine what crazy measurement this would be in inches. Anyway, if we divide this by say 180 millimeters as a desired rise between each step, this comes to 8.088. So we need 8 steps down to the ground. To calculate the exact rise between steps, we divide the 1456 millimeters by 8. That equals 182 millimeters exactly. How would you do that in inches? Maybe I should ask a caveman. Next, we need to calculate how far apart the wooden steps need to be. These are called the treads because you tread on them, and the distance between them called the going. Not sure why it's called this. Maybe it's how far you're going between steps. To work out the going, we take the distance from the landing to where the bottom tread will end, which in this case is lined up with the outer face of the stumps, so is 1810 millimeters. And we divide this by 7 this time, not 8, because there will be only 7 treads. The 8th step is the ground. The going works out to be about 258 millimeters. The treads we have are 250 millimeters wide, so this is ideal. The sides of the stairs are called the stringers. Here we have a nice length of solid hardwood, 200 millimeters wide, 50 millimeters deep, and 2.4 meters long, ideal for our stringer. This gives us enough length so the stringers can overlap the stump by at least 40 millimeters and be flush with the bottom of the beam for the landing. We can then draw in where the cuts can be made from the square ends of the timber. Then transfer these measurements to the timber. That part we cut off. Then we cut to the marks by hand as accurately as we can with an electric circular saw. This should work out square, which it does, dead on. We then measure the distance from this cut and mark a square line as an accurate reference for marking out the other end. This end is a bit more complex to mark out because it needs a tenon cut into it that fits between that twisted beam and the deck of the landing, so it is well supported without relying on any fixings to support its weight, which is good traditional woodworking technique. Cutting this end can also be done with a circular saw, although extra care must be taken with the inside corners of the tenon. And a circular saw won't cut square into these corners. So this needs to be done with a jigsaw or some other saw similar to this. Then we see how it fits. Looks pretty good, although that little point at the top needs to come off. That's easily done. And now it looks even better. We then repeat the same with the second stringer, except this one had to be angled a bit more to fit that twisted beam. If we look across the top of the stringers, we can see how well aligned they are with each other. The next step is to attach the treads to the stringers. The traditional way to do this is to cut grooves in the stringers for the treads to fit into. Threaded rods are then used to hold the stringers firmly against the treads so they don't slip out of their grooves. But before we start cutting these grooves, we need to mark them out accurately, otherwise things won't line up properly. We start with the top tread that is 182 millimeters down from the top of the landing. We measure with a steel ruler rather than a tape measure because this is more accurate for this type of measurement. To get the tread level, from our CAD drawing we get the measurement from the point where the stringer meets the top of the landing, that is our benchmark, to where a line that runs across the top of the tread meets the top edge of the stringer. This is more accurate because it doesn't rely on the accuracy of any cuts that may be off square to allow for that twisted beam. We then mark the groove 51mm wide to allow a 1mm clearance for a 50mm thick tread. The treads won't be dead perfect and we want to be able to slide them in easily. The bottom of the groove must be 250mm wide and not overlap the bottom edge of the stringer, which makes the going of the first step around 284mm, which is 26mm more than we had calculated. This is fine because we need to allow for some capping for the front of the landing anyway, and this will likely be 25mm thick. Although this does mean having to push all the treads over by 26mm, which is also fine because the bottom tread is still on the stringer and having it overlap the stumps a little bit isn't an issue. It looks best if the grooves stop at the front edge of the tread where it can be seen. The groove isn't really seen at the back, so we can run this right to the back edge, which is not only easier to cut, but allows the treads to be slid in from the back. We then mark out the square end of the groove 250mm from the bottom edge of the stringer. We then mark out the remaining treads from our benchmark so there is no accumulative error, with the exception of the last tread that will be referenced from the bottom of the stringer because there is no top edge to mark on. We use a tape measure for this because it conveniently hooks onto our benchmark and we don't have a steel ruler long enough. We then mark out the tops of the treads, then the bottoms, and then the ends. We then repeat the same with the other stringer. We then start cutting with the circular saw set to a depth of around 5mm, getting it as close to the line as possible without any guides, and run a couple of cuts in the middle to help with the chisel work. The end must be chiseled out from scratch because a circular saw won't cut square into the end. Then the rest is chiseled down to the bottom of the saw cuts to get the correct depth. This takes a little while, one of the downsides to traditional woodworking. Once the first stringer is done, we then move on to the second stringer. Although we got a larger chisel this time because it's faster. The downside to working faster is I kept chipping the edge where I shouldn't. Let's hope this won't be so noticeable in the end. Once all the grooves are cut, we then drill holes for the threaded rods. We can now proceed with the final assembly, which will go ahead without any issues. In my dreams. The top and bottom treads are fitted first to get the spacing of the stringers correct, so we can fit the threaded rods with nuts and washers at each end. These aren't fully tightened to begin with because we need to be able to slide the remaining treads in place, and if they're too tight we can't do this. We then proceed to fit the remaining treads. Although we have a problem with tread number 4. Not sure what's going on here. Make an adjustment. No. It appears I haven't cut the groove far enough here. Will I need to pull everything apart so I can get the stringer back on the trestles and make this groove longer? Or, as it happens, chiseling this groove to the correct length with the stringer in place was a viable option and saved a bit of mucking about. That fixed it. Now we can fit the remaining treads successfully with no remaining problems. Although trying to tighten those nuts up on the threaded rod, the whole rod would just turn. That's what vice grips can be used for, stopping that threaded rod from turning. We can then tighten the rest of the threaded rods up, and we're done. Well, for now anyway. We still have balustrades to do, which is the topic of our next video.